Hello and welcome. I'm Sasha, and today we talk about how we can automate the FortiADC application delivery controller with Ansible and Terraform. Application teams worldwide are using Ansible Terraform to automate the application deployments today. Now it's possible for them to build their own load balancer rules, for instance, to take down the link for maintenance, or to set up a canary deployment or blue-green deployment for their application. They can configure web application firewall rules or almost any settings required for their application, independent from network and security. Well, if they allow them to do so. But we hear more of that within my session. Oh, by the way, all the scripts and examples shown in my video can be downloaded from my personal blog page, link shown below. So let's dive in and get our hands dirty, shall we? So let's talk about the demo setup. The whole environment is actually virtualized. So we have a FortiGate in the front, a FortiADC which acting as a load balancer. We have 3 application hosts. It's a Docker host running this my employee DB application. It's a small application, by the way, written in Spring Boot and Java, and has a database, MySQL database in the back. Attached to the FortiADC, we have these 2 Terraform and an Ansible host where we run our demo. Let's dig into a little bit more into configuration. What we have seen on the left-hand side, we have this client workstation attached to the internet, where we can make the request to our demo application. And in the front is the FortiGate, and the FortiGate is attached to the ISV and makes a port forward from the port 443 directly to the FortiADC in the back to the virtual server from the FortiADC. From there we pick up the traffic and load balance it over the reserver pool. It's called the employee DB on the right hand side. And we have 3 hosts. It's the employee DB1, employee DB2 and 3. And all 3 are Linux server Docker hosts and running on the application on port 8080. And the reason therefore it's not encrypted on the backend server, because we want to do that specifically on the FortiADC. Because the FortiADC has dedicated hardware and CPU and is best suited to encrypt and decrypt TLS SSL traffic. So we call that TLS SSL offloading. Therefore, we have to upload a certificate on the FortiADC as well to act as a TLS SSL termination link. If we go into details, we see the server load balancer configuration. And these are the components we need to configure. So we have already seen the reserver pool, employee DB. We have the reservers, employee DB1, 2, and 3. They are already deployed, so we only have to configure the FortiADC part for them. And we configure the health check. We use a very simple HTTP health check, make a connection to the port, HTTP port, and we expect a return code of 200. In production, you can make a more sophisticated health check, for instance, connecting to the Spring Boot actuator health interface and make dedicated requests, even to check the status of the backend DB for instance. But for this demo, I think this test will be absolutely enough. Then we have to create a virtual server, and the virtual server which picks up the traffic from the FortiGate in the front. And as I mentioned, the TLS SSL certificate, therefore we have to create the SSL group and upload the certificate. We already created that, and we have to, with Ansible and Terraform, we have to upload it in advance for using it. And we need to create, for this demo, a client SSL profile where we define which certificate groups we are going to use. And this is a list of some documentation. I think you find that useful about Ansible and Terraform. Let's have a look to that. In the first, you can see this is the Ansible Terraform documentation, and it's coming directly from the FortiADC. Let's jump into it. As you can see, it is from the documentation. I think it's a pretty good document because it shows you how to configure Ansible and Terraform. It's which Ansible role is coming with. It shows how to install the Ansible collection. It's from the Ansible Galaxy collection with the command. It shows you how to prepare the host inventory file and how to make your first Ansible playbook. I think it's very useful here, and finally run the Ansible script with the expected output here. Okay, the same we are doing for Terraform, and how to install the Terraform provider, and with an example of that. And you have to create an API token for Terraform, but we go into that in the detail of the Terraform demo, and how to use the Terraform provider here is with detailed information. I think it's quite useful. And the other is the FortiADC Ansible modules. Let's dig into that as well. What you can see here is the documentation. It's of the FortiADC Ansible modules. It's directly coming from Git. It's a Git repository. And here you can see the most common modules we have. For instance, we can go to the FAT vServer pool member, for instance, and it tells you all the parameters which are required or which are not required, and the description of it. I think that's right useful for you if you create your own Ansible script. And on the left hand side, you can see they even have some nice playbooks already as an example, which you can use for create your own Ansible playbooks and how to configure it with this Ansible modules. The next one is from Forti Development Network. That's a special one because typically you only can get into the Forti Development Network with the invitation from the Fortinet employer. Otherwise you cannot get in. That's a special thing from Fortinet. But anyway, let's have a look into that. That's the Forti Development Network, and as you can see, here is the Ansible Galaxy FortiADC collection documentation. The very important point is this FortiADC Galaxy versioning, and here you can see which FortiADC firmware version is mapped to which FortiADC Galaxy version of Ansible. So here the 7.0 release requires 1.0 Galaxy version, 7.2 firmware, 1.02, 7.4 firmware is 1.1. What is not yet in is the 1.6 firmware version. But I believe it is Galaxy version 1.3 already. What you can see is here as well, run the first playbook. It shows you examples similar to the Git documentation. And below here you can see the modules. Here a list of Ansible module index is similar here. Go to the server pool, for instance, and you see the documentation, the requirements, and actually it's pretty neat here. You can see the different OS version mapping here, which feature, when the feature came in, and if it is supported in that firmware or not. And it even gives you some examples how to use it. The last one is the Terraform FortiADC provider documentation. Let's jump into it. As you can see now here, this page is coming directly from HashiCorp itself. It's the Terraform provider documentation. And here you see the information about the FortiADC provider, example usage information. It looks quite different from Ansible. But if you already know Terraform's usage, so it shouldn't be a problem here. It shows how to authenticate. Be aware in FortiADC for Terraform, you need an API token. That's important. Okay, and with some provider examples, even you can use the VDOM capability of the FortiADC, which actually provides multi-tenancy. On the left-hand side, you can see under the section Global, FortiADC Global Resources, you can see, for instance, the modules, the Terraform modules. You have examples of every module. You have the argument, reference, what you have to provide, which is default. So actually, it's pretty much straightforward. By the way, all this information shown in the documentation and all these links shown here can be found on the description of my video below. On the description, you have all the links there, so you don't have to copy it from the screen. Okay, let's get started with the demo. This is the administrator workstation, and as you can see, this is the welcome page of the demo. So we're doing the FortiADC configuration management with Ansible, and it has the links here to start with the demo. Let's make that bigger. All right. Okay. First, we are checking the backend servers. So the backend servers are ending with 211, 212, 213, port 8080, and we are connecting the Spring Boot actuator health interface to see if the interface is responding, and it does. It shows the status up. But we can check it in the browser as well. That's what we are doing right now. So we go to the browser of the first interface. You see, it's empty now, we don't have any data. Database server is empty, so we can implement something. Here we go, so we have our first user. So that's working smoothly. So let's check the second user because they are connected with the same database. We can check the second user, so we still should, the second server, we should still see the same data, that's fine. We can check the third one, that's fine. So all the three backends are running smoothly. Let's check the FortiADC as well. That's the FortiADC dashboard. So we don't see pretty much right now. It's not really much configured. So on the left hand side you see the dashboard, and what we are really interested is the server load balance section with the virtual server. There's no virtual server configured yet. We have the application resources, client SSL, there's nothing there right now. And the same acts for the real server pool, there's nothing configured right now. We are about to change that pretty soon with the Ansible and the Terraform demo. And going back to the application, even the application itself, from the load balancer side, from external, it's nothing configured yet. So if we press to that page, we don't get a response. Makes sense, because the load balancer is not yet configured. Before we start with the demo, let's have a look to the FortiADC. And this is the dashboard of the FortiADC. You can see there's not much configured right now. So on the server load balance, virtual server, we don't have a virtual server yet. Application resources, client SSL, there is where we have to create the client SSL profile. There's nothing configured yet. And the same acts for the real server pool, there's nothing here. And we can take a look to the managed certificate. The same here, we don't have a certificate group for now, and the local certificates are empty, at least for our demo application. Then let's continue with the demo. Before we can create our first playbook, we have to define a variable file. A variable file is used because we don't want to hardcode all the values in a single playbook. We are going to use that playbook for different use cases, different hosts. So we want to have a variable file where we have the information needed for our use case. In this case, the employee DB application. So we have defined it here, the pool name, we have the virtual server name, the IP address of the virtual server, which port of the FortiADC we are using, which interface we are using, which port 443, the protocol virtual server type is HTTP, and so on. We give them information where we can find the cert. It's on the local drive. It's a certificate, and the certificate key is there stored. And we want to create this employee cert group we need, and this client SSL profile. All this stuff is defined in a variable file. Which is really special here is the real servers. And what you can see here, this is an array in YAML. So we have real servers as an array name, and then we have our 3 real servers configured here. The playbook later will loop through this array, and this is very special. So we make all 3 servers here. So we have starting with ID 1, 2, and 3, and the different IP addresses and the host names. Okay. To make it secure, we don't want to store the passwords or access parameter for the FortiADC on the playbook as well. That's not safe. So we are doing that with Ansible Vault. We are creating a file with our secret password. So it's not so secret anymore, but as it's a lab environment, so that's safe to show it here in that video. Okay, so Fortinet is our password. We store that in our home directory and make permission read only for the owner. So not everybody can read it unless you are super user or root. And this is the file, okay? This is the vault password. It's not the credential for the ADC yet. That's what we are doing now. So we make a temporary file, And here are the access credentials for the FortiADC. Important is we are using, similar to the variable file, we use this FortiADC password variable. And later we reference to this variable. Okay, it's the same password and it's stored in that file. And what we are going to do now with Ansible Vault Encrypt, we are encrypting that file. So encryption was successful. And when we take a look at that, so it is an encrypted file. And that's pretty cool because now this file we can safely add to a Git repository or whatever. So store it with your application because you cannot encrypt without the local password we created here. This is the FortiADC password here, the vault password. Okay. And now we are going to create the inventory file, and that's important as well. So here we define our FortiADC or pool of FortiADC because it could be possible that we have multiple of these FortiADCs, and you want to change settings on all that, not just to configure a server load balancer. Maybe you want to create some settings on multiple FortiADC. You can define that here. And it will list through that. So if you use FortiADCs, it will loop through all the FortiADC. Define it here. Okay, that's the connection definitions here. And very important, this is the operating system. So this is for the answer to select the right Ansible module. Okay, Fortinet, it's a hierarchy, fortinet.fortiadc.file. FortiADC OS. That's important, otherwise you cannot find the right Ansible modules. Now we're about to create the playbook itself, and yeah, that's a big one, but I guide you through it. Okay, so we have here our FortiADC hosts where we run this playbook. Okay, so if we reference it here, this is from the inventory file, so it runs in this example only on this single FortiADC. And we have the collection we are using, that's the Ansible Galaxy collection, so which we already have installed. That's the connection protocol, it's an API. And we don't use the fact sheet. We have the variable file. That's the vault path, the credentials we use that file for the ADC connection. This is what we have done here on top of it with the encrypted password. Okay, and here is the loop. That's the interesting part. So we are about to loop through the reserver hosts. And here we create the vService itself. So we make an add, we create the new service, and you see this in this curly braces, this is the variable names we are using. So we have here in this section, we have action, we add, we have name, IP, status, and VDOM. This is the things we have defined here on top. These are these values. And we loop for each of these reserver. Okay, that's the loop variable. And we loop here first, so we create the reservers. Okay, so here's the loop variable. And second, we update it. Okay, so we create it and even update it. This is a thing we need to make sure that all parameters are created correctly, because it can be that the server already exists, but it has a different IP address or a different status, different settings, so we change it right away. As you can see here, Fortinet didn't really do this Ansible modules idempotent. Okay, so usually you are not working with actions. So usually you define a target, and the target is set.
what you want to have as an outcome, okay? And but Fortinet is using with actions to add and create and delete, okay? So it's not 100% Ansible way how it should be. Then we create the health checks. This is our health check I mentioned in the introduction of this demo. So we only make a simple HTTP request to the slash endpoint of the application, and we check if we get return a status code of 200 back. Okay, so in advanced mode you can do much more complex health check modules that really connect to the API of the application or the actuator health interface to check the status of not only the application, even the database in the back. Okay, that's best practice. And after creating the reservers, we are now creating the reserver pool. And the same, all the information comes from the variable files, and we use the health check we have just defined. And in the pools, we just add, it's an additional step, we add the real servers we have defined above, just above. Okay, so we created the pool and now we have to add them to the pool. And now comes the part with the certificate. So we are using the certificate upload. This is the cert key module. And we are using the upload feature. So we take the certificate and the key from the local file system, even that the SSL cert name and the key we have stored in the variable file. Then we create a certificate group. And next step, we add the certificate we just uploaded. We have uploaded. That's the one with that name. So we created it before here with that employee DB SSL. So we add it to the local certificate group. And now we are building the client SSL profile. That's a big file. Usually you can use a template from another one, but it's a lot of stuff configured. Here you define actually which SSL version you are going to support, which features are enabled or not. This is a certificate verification, for instance, and here is the our TLS version. So we are doing only TLS 1.1 and 1.2 here, the encryption, and so on and so on. You can customize that as you need it. But an important fact is we give here as well the SSL certificate group. That's an important thing. Okay, so that's, you say, use that certificate group with the certificate included in that group. And at the end, we create the virtual server. And the virtual server is actually the listener is an IP address, a listener on the FortiADC. And we already have configured on the FortiGate a port forward from incoming port 443 forwarding to that server. And so we give him the server name, IP address, just as defined in the variable file. Before we run the playbook, let's get one step back. While explaining the playbook, I mentioned the term idempotent. What does that mean? In Ansible, idempotent has a clear definition. It means, in Ansible, idempotent means that running a playbook or task sometimes produces the same result, making no unintended changes after the first successful run, ensuring consistent system state by only acting when necessary. What does that mean? In idempotent, you typically in Ansible define a desired state. For instance, in our case, we want to have a virtual server configured up with a name and an IP addresses and the status running.
That's the state. And so Ansible, when it runs, it checks if the virtual server is already running. If yes, it checks all the interface name and the status, and maybe you have to adjust the IP address, but it only makes the necessary changes required. If you run the same Ansible playbook a second time, all good. Okay. As I have mentioned in the Ansible playbook for the FortiADC created by Fortinet, we using actions. And it's not forbidden to do that, but it leads some issues, okay? So if we have the first action was create a virtual server. If that virtual server already exists, you get an error. If it doesn't exist, he creates the server. That's fine. But actually, we want to define a desired state, so we don't want an action. The same acts for delete. Okay, if we want to delete a virtual server which does not exist, you get an error. And that's the big strange actually from idempotence in Ansible. Typically, the vendor is responsible to make all the necessary checks. For instance, if you want to create that virtual server, then Ansible has a lot of Python code in the back that verifies if the server already exists, I don't need to create a new one. Okay, I only have to check. It's a lot of code, a lot of if, and typically the vendors are responsible for that part. So that's the explanation. So we have to deal what we have. So Fortinet only provided this kind of Ansible module. It's not perfect, but we can deal with it. So let's get back to the playbook and let it run. This is the command to start the script. Okay, it's a three-liner, but it's not that hard. I will explain it. So Ansible playbook command starts the playbook, and we give the name of the playbook. So far, so good. Then we need some more information. So with -i, we give the inventory file containing all the servers we intend to run against it. Okay. Then we have provide the extra variables, and this is the file containing all the configuration settings we saw in the beginning with all the variables and parameters defined. So with this option, it makes us possible to run the same playbook, but with a different variable file for a different use case. And the last line, so we have the vault file. So we run it with our vault password credentials. Okay. Typically, as we have our vault password already given, he can read it from the file system directly. If I don't provide that option, vault password, he asks me that from the command line. But usually that's not what we want, because think about it, if you run the playbook in a DevOps process in an automated way, you don't want to have that script interactively. So you want to have that automatically takes the password file from the file system. Typically, this is a machine that regular users don't have access anyway, so it should be safe. Now, we run the playbook, and as you can see, a lot of green is pretty well good. But the first step, you see all the tasks related to the task we have configured in the playbook. So the first task is we do the real servers and change the status to enable. Okay, and what you can see here is we have 3 lines, and this is because we loop through the real servers. You see the first is ending with IP address 211, 212, 213, so all works fine, so we create that. The second is we update the IP address of the real servers. That's good. And then we create the health check. That's a single object. That's fine for now. And then we create the real server pool for the backend servers. And then again, we have to manually add all the backend servers. That's a loop as well. So the real server we just have created, we add to that real server pool. Okay, then we upload the certificate and create the certificate group, add the members, so long. And we have the SSL client profile.
we just created, and at the end we have created the virtual server. Now we can verify if the deployment was successful, and therefore we make a call to the external interface of this application. So employerdb.apps.fortidemo.net on directly to the actuator health interface. As you can see, it is coming up. The interface is up and seems to work. So now let's test if we can access the application from the web browser. Therefore, we go back to our main menu, and this time we try the external link, and yes, we are here, we are encrypted, and we have a secure link to our database. Let's have a look what we have configured on the FortiADC. On the FortiADC right now, if we refresh the screen, you can see here we have a virtual server interface. That's new. So let's have a look into it. So we go first to server load balance. We take a look on the virtual server, and yes, wonderful. So we have the virtual server as intended, the external IP address. We have the client profile. So let's take a look into it, what he has configured. Okay, so it's a layer 7, its status is enabled, nothing more here in general. So we see the IP address, then we see the profile, it's HTTPS profile. This is our client SSL profile we just created. And some additional configuration, there's not much configured here. Okay, let's take a look to the other values. So in the application resources, we have this client SSL, and here is this client SSL profile. That's what I mentioned with the cyber settings here, and the important stuff is here, just the certificate group we need to add here. And here's the real server pool we have created. Let's dig into that. And here are the 3 real servers, 1, 2, and 3, with the status active on port 8080. That looks pretty good now. The last thing we verify here is the certificates you need to have created. Now you see we have a certificate group, and if you take a look at that, it is our certificate is configured here. Perfect. Let's get back to demo. Now we want to create some traffic to the load balancer and see how the load balancing works. As you can see, the traffic is linearly spread across all the 3 real server, backend servers, where you can see in the green one. That's a perfect round robin. Now, let's change the weighting of the real servers. Therefore, we want to have the first member to have a weighting of 1, the second a rating of 3, and the third member a rating of 5. 5 means the higher, even higher this number is, even more traffic is about to get. Therefore we change the settings in the variable file. As you can see in the YAML, we have now the weight to 1, to 3, to 5 adjusted. And we are about to run this playbook again and just change these values on the backend server. Okay, so this is a smaller version of the playbook, so we only have to adjust the real server pool members for now. Let's run it. as you can see, we have one of the task has been changed, marked with this number 1 here, and you see the values have changed here in the back. As you can see, now the first member got the least of the traffic, and the third member got the most of the traffic. So can you change the rating of the load balancing. Now let's make another test, and what happened if we disable one link? That usually can happen if we take one link down for maintenance, for instance. Let's do that. Therefore, we adjust the variables as again. So you can see link 1 is enabled, link 2 is disabled on the second host, and the third is enabled. Now we keep the playbook. It's only modify the reserve pool member status, and let's run the playbook again. As you can see, there is one change happened, and it is the status which has changed for the second repool member. And as you already can see from the traffic below, only the first and the last member are getting some traffic. The second member is completely disabled. Now we have seen how simple it is to deploy a configuration with Ansible. Now we are about to clean it up now. Therefore, we start the delete script. For the cleanup, we are using the variable file we have created while deploying the virtual server. And you can see it's pretty much the same here, but the playbook will change, and the main difference is we have every task in a reverse order, and that's important because many of the objects depending on each order. For instance, the virtual server object is depending on the reserve pool member, and so on. So you cannot just delete the reserver while you still have configured the virtual server on top of it. Okay. The delete is slightly different. It's a smaller, you don't have to provide anything, it's only just the action. Here's the same problem with the idempotent thing. So you give an action, and the action delete, and you expect that the virtual server object is already there. So if it is not there, you will get an error. And so we delete that. We only have to provide the action and the name, and we delete the reserver pool members from the pool. Then we have to delete the pool. Then we can delete all of the reservers, the backend servers, and you can see it's a loop again. So we loop for all the 3 hosts we have configured here on top in this array. Then we delete the health check, the SSL profile, client profile, and then we drop the certificate from the certificate pool, and then certificate group. And then we can delete the certificate group, and at the end we can delete the certificate. So let's run that. So the virtual server is already gone. Now we're moving the member from the reserver group, from the pool. That's done. Now we delete the reserver, the health check, SSL client profile, the certificate group and certificate, and we are done.
As you can see, it's very simple to make configuration management on the FortiADC with Ansible. It's very simple, and even you can automate it as part of a DevOps process. The next part of the demo will be Terraforms. See you soon. Now for the Terraform demo, we are doing exactly the same like with Ansible. Let's see here our landing page of the demo. So it looks similar to the Ansible demo, but we have here the Ansible server. And let's check the environment first. Okay, so we have here the backend servers. They are still deployed from the last demo. All three are running. That's good. The main application is not deployed. That's the reason we got a side error here. So then let's start with the deployment script. We have already verified the backend servers from the GUI, but we do it from the CLI as well. Again, we are connecting to the Spring Boot Actuator Health API and can verify if the server is up. Now we have to do something similar to the Ansible, so we don't want to have the secrets hard-coded. So we are generating a secrets file in the home directory with variables. So we have the FortiADC host name, which is the IP address, in fact, and we have an API token because that's important. FortiADC uses an API token for user to log in. If we switch to the FortiADC dashboard, you can see it's already empty, there's nothing configured right now. So when we go to Systems and we go to Administrator, we can see we have API admin user. And here is the API key. I don't reconfigure it, you can generate it, but we keep that existing key. But here we can define for this profile, super admin, the API key. You can even check the profile, it's on the access profile here. And you can create your own profile and restrict access only to that value you really need. For instance, server load balance. In my case, I activated anything here. We have stored the API key now in this secrets file, and now we change the permission to read only. So here we go. And now we create the Terraform configuration files. And these files is a separate file for every configuration we have, like the Vitro server and the health check, for instance, we see it. And this is the variable file. And here we have the FortiADC host name. This is actually resolved from the secrets file, and the same it is from the FortiADC token is coming from the secret file above. Here we go. Now we create the variables file. And here are all the variables stored we need for the deployment. As you can see, it looks a little bit different to Ansible. It's more like functions, as you can say. So we have, for instance, the real servers here as object, is an object map, a string. And it's the same here, it's an array. So we have this. It looks a little bit different, but it's still to Ansible, but it's still an array configuration. So we have reserver DB1, reserver DB2,
and DB3 with all the configuration, port configuration, IDs and so on. Then the next is we have the vServer pool name here. That's the description to it. Employee DB. We have the virtual server name we use for the installation, virtual server address, port from the FortiADC port, interface port, and the port number. Then we have the health check, same here, so the health check name. Then we have the certificate part as well. Here's the name of the certificate it will have if it is uploaded. And here is the source. So we have the certificate and the certificate key. And here we are defining the cert group. And the last thing is the SSL client profile we define here. The first file contains the certificate configuration. Let's have a look. So it's divided in multiple sections. So the first section is the certificate upload. And in this object we have defined the cert and cert key. It's defined in the variable file with the absolute path, with the certificate and key. The next is the certificate group as well. This information is coming from the variable file as well. So we have the group name. It's all happened in the configured in the root vdom. The next one is the child member. So we have uploaded the certificate. Now we are adding it to the cert group. We have defined it here. So that's a dependency. So this object depends on the cert key upload, if this is successful, and from the cert group, from this one. It's a dependency. Then we have the client SSL profile we need. So we have some SSL definitions here, for instance, which TLS versions we are accepting. It's 1.1 and 1.2 in this case. We have the certificate group, which we have defined before. We take the name from the variable object. Yeah. That's all from this file. The next file is, we have a look in the health check configuration file. And in health check, you see, that's the name of the health check, HTTP 200. So the check is basing on HTTP, IP44. We make a request on the slash, and we expect a return code from 200. Here are some interval and timer settings. Here you can, similar to Ansible, make a much more sophisticated health check. For instance, you can access the Spring Boot actuator interface, the health interface, and even it's possible to have additional actuator endpoints, for instance, the database. So you can make a check, is the database up and running and accept traffic and load. However, we are happy with that one for the moment. The next one is the load balancer. In this file, we are going to design the vServer pool and the vServers itself. So this first object is defining the vServers, and as you can see, each key, this is a loop. So in the variable file, we define it a block with all the 3 vServers. Here we are looping into it and define these servers. The next one is we creating the pool with the employee DB pool itself. It's in the root vdom, and we are using the load balance as a health check we have defined it before. So we have here a dependency. So Terraform makes sure that the health check object has been created before. The next one is we add the real servers we have created before to the pool. The same here, we have a loop. We have a loop for each real server. The same here for each ID and for each port number. It's a toString. It looks a little bit more complicated than we had it in the Ansible part, but it's more or less should be fine here. And the next one is the virtual server. That's what we're creating here, and this is the configuration for it. That's the name of the object. The name from the virtual server is coming from the variable as well. We create a level 7 load balancer. It's in the root VDOM, and the IP address is coming from the variable file as well as the interface and the port number. And now we are about to start the Terraform script. From the command line, it's much shorter than the Ansible one. And you will see even from the execution, it goes much faster. So first we have to initiate it. Okay, so he creates the directory structure, anything related to the Terraform script. And the second script is we create the plan. That's what we're doing here. And we give the plan a name. So we store the configuration. This is the plan, what we have to install, what not. We have the variable file. Exactly, and this is the folder we have all the files. Okay, let's go from the start. Let's review it then. It's a lot of information. Okay, this is all for every profile or for every component we have as a resource actually. So this is the FortiADC client SSL profile, and you see all the settings we are about to create or change. The same for the load balance, for all the components we have defined, you will see such profile setting. Okay, it's a huge file, and this is now the created plan. So there's all the resources. And on the FortiADC, the components we will about to change. So we have 13 resource objects we are about to add. And now we do the final step, so we execute the plan. And that was it. Let's test if we can access the web interface of the application. Oh yes, pretty good. So we have status up. So we make a request on the actuator health interface of the application directly from the outside link. That looks pretty good. And now let's verify from the web browser directly. We are back on the admin workstation, and let's have a look for the external link here. That looks pretty much good. So we have a valid certificate here. That's the external link. That works. Now let's have a look on the FortiADC. What's configured there? So we have to refresh the page. And as you can see, yes, we have a virtual server here configured. Let's check the details. On the server load balance, we have the virtual interface. It's a layer 7. It's the IP address is correct. We have 443, and have a closer look to it. It's a layer 7 load balance configuration, and the general tab with the IP address configured. So we have the client profile and the client SSL profile. We define it. And we have the round robin method, load balancing method configured. From the application resources, we have now there is the client SSL profile. And as well, the real server pool should be there. Yeah, it's a real server pool. Let's dig into it. and we see the backend servers 1, 2, 3 configured here, and with status ready on port 8080. The last thing we check is the certificates. So we have the certificate group here, and we have our EmployeeDB SSL certificate here. Going back to the demo, let's do the same we did with Ansible. Let's create some traffic on top of it. As you can see, so we have a load balancing method round robin. So we are evenly spreading the requests across the 3 backend servers. Now we try changing the weighting on the servers. Therefore, so we have now member 1 with weighting 1, 2, and 3. Therefore, we have to change the parameter of the config file. So this is the variable file. Let's go back. And we can see we have the weighting information, weight 1, and the second server has 3, and we have here 5. So the EmployeeDB 3 should have the most of the traffic. That's fine. Okay, let's kick it. So we changed the plan. Now we execute the plan. So we see what will change on top of it before we execute it. Okay, we see this is we only have modifications on EmployeeDB 2 and 3 backend servers. The rest remains the same. That's pretty what we expect. So let's kick it in. That was very fast. And now we are executing the load already. And as you can see now, that's still more or less a little bit shared, the traffic, but yes, member 3 is getting definitely more requests than the other twos, and server 1 almost nothing or only a few requests. Now we make the final test. We want to make sure what happens if we disable a link. We do that with Terraform as well. Okay, so we take the number 2 offline. Let's verify the variable file here. So we have here server 1 enabled, server 2 status disabled, server 3 enabled. Weighting is the same as in the beginning. That's fine for us. So let's execute the plan. As you can see, we have only one change, and this is the change to disable of the server 2. Let's kick it. And let's see what happens with the traffic. And yes, as expected, we only see traffic from the backend server 1 and 3. And this feature is pretty useful if you have maintenance on the backend server. So you can take it offline, you can upgrade it or patch the server, and with no interrupt of the traffic. So the load balancing just happens to the remaining 2 servers. Now let's clean everything up. That's an advantage of Terraform, because you can use the same config file. You don't have to make especially a deleting file like we had in the Ansible. So you can just say destroy with the same configuration. That's pretty neat. So we are about to delete the whole configuration with the Terraform destroy command. Oh, boom, that was pretty fast. Let's see it, 13 object destroyed. Let's go to the beginning. We have a closer look. Here we started. So yes, the SSL profile is gone for the client. We have the pool is gone. So we have the members deleted from the vServer. And then the vServer itself. That's already the virtual server which is gone, the third group and the membership and so on. And we have the health check. Yeah, now almost all objects are gone. Now let's have a look on the FortiADC, how the cleanup worked. So you can see the virtual server is already gone. Let's have a look to the virtual server. Yes, there's no configuration anymore. Application resources is gone. The client SSL profile. Then let's take a look to the real server. The real server pool is gone. The real servers are gone. And now have a look to the certificates. Here we go. Yes, all the certificates are gone as well. So that was it. We are at the end of the demo. We used Ansible and Terraform to automate FortiADC. That leaves the question at the end, which one should I use? That's actually a personal decision, or depending what you're already using in your corporate. My personal view, I prefer Ansible because the steps are more independent. So I can make a playbook, and every step is a separate call, and it doesn't require to have a configuration stored locally, like in Terraform, where you use local state files. And if you mess up with that state files or lose it, you're getting in trouble. Nothing an experienced Terraform user can fix, but I prefer, in my case, Ansible, because he doesn't care what's there. So before he starts the playbook, for every task, he take a look what's there, what I need to change to have the desired state. But at the end, it doesn't matter what you choose, and take your personal favorite. We are in the end of my blog session, and I hope you liked the video, and I hope we will see you next time when it calls. Let's get ready. Bye bye.